So the second topic is about strain. So the strain is a product of stress, where stress is P over A, and the stress definition is the strength per unit length of the material, while the strain is its deformity or deformation per unit length. So strain strain here is defined as deformity per unit length. So that's strain. So whenever na ay stress, then there is strain. I know you're familiar with strain. It's a product of kanang after doing strenuous activity or very kanang hard activities, physical activities, so maka-feel kag helpless sa imong self or like imong body. So kapoy imong body. So it's strain. So basically, we're going to focus only with the proportionality limit of the material from that's actually from point O until this area here of the graph. So this is the proportional limit. So that's the same amount of strength or stress is also the same amount of strain. So we can equate that stress is proportionally directly proportional with strain. Okay, so that's how we deal with stress and strain. So naatay gitawag nga proportional limit. So this is the portion at which we're going to expose the material to its proportional limit strength. So kasagaran na tong exposure sa atong material kay diha ra kutob, because we cannot go beyond that since it's a different kanang area of concentration. So let's just consider first the proportional limit of the material from stress to strain. And then as you observe here, you have this is Hooke's law or the proportional limit equation. So this is stress is equal to the proportional limit constant times the strain. So this constant here, K, is attributed by modulus of elasticity. Since we're talking about the stress of the material and the strain of the material, then the common denominator for the two is its rigidity and elasticity. So later on, ang rigidity kay i-discuss na sa sunod nga topic, while mag-start lang sa ta with the elasticity, since we're trying to kanang apply forces of the material along its longitudinal section. So basically it's compression or tension. So somehow it could either be compressive or tension. So shrinking and stretching the material ang atong gi-consider. And we have the elastic limit. So this is the limit at which the material is exposed to a certain force nga dili na siya mag-go back sa iyang original position or sa iyang original shape. Just like rubber bands. Whenever you try to expose rubber bands with tensile force for such long hours, then the rubber band won't go back to its original kanang shape after releasing the force. And then the elastic range is the range from 0 to P. So diha ang atong proportional limit. And then the plastic range is from P to R. Diha na to makita ang physical attributes sa atong material whenever ma-expose siya sa certain amount of force. And then yield point, this is yield point because at this position or at this point, the material kay mo give na og mga physical changes, like nana siya yung mga blisters or nana siya yung mga cracks. So blisters kung nagiskuta og timber, wood, or steel. Then cracks whenever magiskuta og mga blocks, mga masonry blocks, and reinforced concrete. So diha na to siya makita yield point. So it's the physical changes nga ato makita sa ato ang material. And then the ultimate strength and the rupture strength is basically money iyahang proportional, iyahang ultimate limit or limits atong material at which pwede nato siya ma-expose to certain amount of stress. And then the rupture strength is the strength of the material nga naabot na siya sa brink sa iyang breaking. So before ni break ang atong material or before siya ni split, no? Before siya ni split, ang material na to kay naabot pa niya ang rupture strength. So at the brink of splitting diha ang atong rupture strength. And basically, let us just continue with axial deformation. So axial deformation is derived from ano na deformation? Okay, remember that strain is the deformation per unit length. So basically, since nagisgot man ta og strain, then we are going to quantify the amount of changes of the length of the material, may it be in shrinking or in stretching, or shrinking kung compressive, then stretching when there is tensile force. So axial deformation, tungod kay ang atong force is an axial force. It could either be compressive or tension. So remember this one from Hooke's law, that stress is equal to the modulus of elasticity times the strain. So how do we get this formula here? It's basically from this one, kana siya. So ato siyang i-derive something like this one. Stress is equal to modulus of elasticity times strain. Then stress is P over A, as we all know, and then equal to E times the strain is the deformation per unit length. So muna siya, no? Since we're solving for deformation, so may mo siyang mabalhin na to ang L padung sa numerator here. So deformation times E is equal to TL over A. And to get the deformation, ato ibalhin si E sa denominator. So it's now PL over AE. So as you can see, it's the same there. So that's axial deformation. So axial deformation kay a force could either be a tensile force or a compressive force. So it's always acting perpendicular with the cross-sectional area. So that's why it's called axial, tungod kay axial force atong gigamit. Then axial deformation. Okay, so let's have this one, the summary of the elements. So we have deformation or delta, the small letter delta. Deformation is in mm or in inches. And then P is the axial force. That's either newtons or in pounds. Then L is the length of the material in mm or in inch. And then A is the cross-sectional area of the material. And then E is the modulus of elasticity. That's in megapascal or in PSI. So this E is always given since this is a constant value. So this is an arbitrary constant. No, empirical rather. So empirical number. So this is modulus of elasticity. Whenever the problem asks you to solve for a certain stress or deformation, then there should be modulus of elasticity to describe the strain of the material. If wala, then maybe the problem suggests you to solve for the answer in terms of E, or maybe the problem wanted you to solve for the E, or maybe the problem is erroneous. You better ask your instructor or whoever nga maka-answer sa imo. So that's about the introduction. Let's proceed with